Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Well, you might remember a few weeks ago we fixed up several TI-74s and TI-95s, and we didn't quite get to the accessories then. And then did another video about restoring boxes, and I used those boxes as an example. So today we're going to get to the accessories, which is the last of the stuff that's been sitting on my workbench since last year. So we've got a printer, we've got the cassette interface. This cassette deck we refurbished last year sometime. So we're just going to use that to test the cassette interface. And I've got a few more TI-74s here, and those are just unique ones we're going to have a quick look at. And this one has a really busted case, so we might try to see if we can fix that up and make it solid and still look kind of nice. So let's get started. Thanks to PCBWay for sponsoring this video. They not only do PCBs and flex PCBs, they also have 3D printing service, injection molding service. They do CNC machining, sheet metal fabrication. They also have a thriving maker community where you can share projects and check out what other people are doing. For your next project, head on over to PCBWay. Thought we would start with the little PC-324 printer. You see the label here. This printer was property of Auglaize County, Ohio. Now there is somebody quite famous from Auglaize County, in particular from Wapakoneta, or Wapak as the locals call it. That is the boyhood home of Neil Armstrong, the first man on the moon. And of course this printer has no connection with Neil Armstrong, just from the same county. There is the Neil Armstrong Air and Space Museum that's in Wapakoneta, Ohio. So if you're ever around that area, you might want to stop in and see that. This cover slides off this way. I had it partially off because it's kind of a pain in the butt. And you can see we can use 4 AA's. It's got a paper advance button here, which is kind of broken. Thermal printer here. I swiped some thermal paper out of a sharp printer, which I think will work in this. And then you've got the Dockbus style connector, which is Hexbus in a line instead of in the 2x4 dealy bob there. So there are 4 Phillips screws on the bottom, so we'll pop those out. See what's on the inside, see what's up with that paper advance button. And we'll try to clean and lubricate that printer before trying to fire it up. It also has a DC input jack on the back, although the manual just doesn't tell you what voltage it is or the polarity, and it tells you the part number of the adapter though, and it's not marked here on the device either, so I'll have to figure that out, and I'll add a little sticker here. And it doesn't say on the back of the device either. I'm guessing it's about 6 volts since it takes 4 AA's. And so, you know, back in the day, having rechargeable batteries was nice in a portable printer, but it's nice for us now that it doesn't, and nobody left the batteries in here, so nothing corroded. Okay, we want to go like this. Don't know what. Oh, that's from the bottom of the printer there. There's some sealant on that stuck to this. All the parts came out in the top. So we have a control board here. A little flap here to our battery compartment. I think the cord comes loose like that. Yep. Oh, this stuff on the cover is the sticky from this foam here. So they had it glued down with a piece of foam to make it a little quieter. And how do we get our Mr. Printer out of there? Looks like it's got another piece of sticky foam in the top, gluing it in. Okay, here's our whole thing. What I did is reached down through the cover and let me get this around right. And kind of pushed on the top of the printer, and from the bottom I dug at the sticky tape, the foamy tape with the plastic spudger, and that got that off of there. There's still some, the rest of the foam right there. So I'll have to glue it back on there with something about like that. The printer looks okay. It's marked HMEI or HME1601 16G12. Just your standard little thermal printer. And it has a flat flex over to the circuit board. And then we've got our paper feed switch right here, which has no spring in it. Or no spring back, I should say. There's no spring there either. And you can see these two pads right here. That is what the battery holder presses on. So I think I'm going to disconnect this ribbon. I already drew some marks on it. So hopefully there's no way I can get that confused. There's a connector there for the wire. And I don't know how that's supposed to be marked. Oh, so there's a dot. There's a white dot right there. I'm just going to put a black stripe right like that. Couple of electrolytic caps, but these are big axial guys. They look fine. I'll test them in circuit. I don't expect they'll be bad. There's a pico fuse there. Some tantalums. None of those look suspicious. I don't know if we can get maybe there's a hole in the bottom of that switch that we can push it up out of there. I'll go ahead and turn on the soldering iron and we'll see. There's our power jack. And it's looking like it might be center negative, but we can find that out with the voltmeter. We can touch like the center, touch the ground on one of these chips, which is a common chip. So like this is a 7400 series chip. So we can go here to pin 7, figure out which one of these is ground, and Bob's your uncle. So I'm just going to try to walk this switch out of there, heat up one leg at a time, tip it over a little bit. Okay. And I did ohm this out with a meter. Yeah, let me zoom in here. Okay, so this is center negative. Negative comes in here, goes through this big resistor, down through this diode for reverse polarity protection. So if you test from this side of the diode to like the negative of the 7400 chip or the negative from the battery, there's less than 1 ohm. So center negative. Here is our switch. There we go. Okay, there's just 2 little copper pieces there, and a bit of dilapidated, looks like that might have been a dome of conductive rubber. Just rather dilapidated now. I don't know. Try to ohm that out and see what we get. There's some crumbly bits. But something made contact with the bottom of that, and there had to be something kind of springy about it. Let me ohm this out real fast. Okay, you guys can't see the meter, but I'll tell you what it says. Tricky little thing. And of course the meter's on millivolts. It's about 5K on the center of that, and the outside of it is 4K. And the rest of the plastic is open. So this whole, don't know if you can see that. There's kind of a round part in the middle here that goes down to there. It looks like that whole thing is conductive. Now, yeah, I just popped it out of there. So whatever that was, whatever sort of switch that was, it's not any longer. So I wonder if I can find one of those tactile dome switches that'll be the right height to sit in there. Have to look in my stash. We'll have to fix that. And check these caps. You can't see the caps. Got this cap and this cap to check. So I looked in my bin of miscellaneous tactile switches, and I found a couple possibilities. I had one like this, which is about 10 millimeters from here to here, which matched the original switch in height, but it was surface mount, and I tried to bend the leads around to get it to solder on there, and it just wasn't going to work. So then I took a 5 millimeter switch like this, which had through-hole leads. I cut a couple of them off and mounted the switch diagonally, and the leads fit through the holes on the board like that. And then I took the original plunger from the switch, turned it upside down, and glued it to the bottom of the part you poke with your finger there. That took up the difference, the extra 5 millimeters that I didn't have here, and it used as part of the original thing. So everything, you know, that should work out just fine. I just need to wait for the glue in here to set up. And I checked these two capacitors with the capacitance checker component tester thing, and they are both just fine. So we're good to go. We need to move on to the printer now. One other little fix I did here on the control board after putting the new switch in is I noticed that this battery contact pad had holes in it right where this guy was pressing on, probably just from years of slightly shifting position. So I took some copper foil, cut it a little shorter than the pad, soldered at the ends, tinned it, you know, that type of thing. So it's kind of ugly, but it'll do the job just fine. We need to lubricate our printer mechanism here. And to do this, I've got some grease here. I've also used lithium grease in the past. Either will do. I bought this for my 3D printer. It doesn't get quite as messy as lithium grease in that environment, and it'll work fine here. So I want a very light coat on the shaft that it slides down and the worm gear here, so that both lubricates it and it cleans off the old lubrication. There we go. Nope, you can't see that. So you see how it looks like it has that crisscross pattern on there? So it's kind of cool how it operates. When it gets to the motor runs the same direction. You don't need to reverse the motor. Why did that just stop? When it gets to the end, it slips into the other groove. It goes the other direction. So the motor can run continuously, and the carriage automatically changes directions at the end. Huh. Try to get all that old grease out of the grooves. Get all the spots on the guide shaft. Now I stuck a piece of double-sided foam tape up in here, but what I have has a white foam. The original is black, so I took my Sharpie marker, colored the edge, so when you look down through here, you're not going to see that white tape. It'll look black. A little camouflage there. All right, when this is assembled, I finally figured out that it's supposed to set in here like this, and there are alignment pins for things. And the tape on the bottom of here sticks it down. And then when you put the top cover on, the tape here will stick down to the top of it. And one of the pegs here was bent, and I tried to straighten it up and broke it off, so I'm going to have to glue that back on. And I'm going to have to apply some double-sided tape to the bottom of this. This is about 3 millimeters thick here. Yeah, so I'm going to have to build up some layers of what I have into the C shape, and then I think we can kind of set everything in the bottom tray here, temporary like, so we can test it, make sure it works, so we don't have to deal with that double-sided tape again. So I am using the power adapter from a TRCD Model 100, which is also 6 volts, it's 400 milliamps, center negative. I looked up a picture of the original TI power adapter online, and that was its specs. I figured it should work. If we plug this in, no, it didn't do it this time. If this is away from home, it may home itself. Okay, we'll turn the 74 on. I don't know how well that's going to show up on the... That's a little better on the video. Okay, so we should be able to feed some paper. Better get my old man glasses here so I can actually see what I'm doing. Okay, so we've got paper in here. Our bodged in switch works there. I was worried about that only having 2 points of contact, like this and this, and it might tip. So I took some E6000 glue and put some glue around the periphery of the switch. That way it'll hold it in there solid, and if the switch needs to be replaced 30 years from now, that glue will just peel right off the board. All right, I typed a program in here that is out of the manual. Now, the printer manual tells you how to add batteries, how to add paper, etc. It doesn't tell you how to use the printer. And if you look in the TI-74 manual, the user manual, it says, well, if there's something on the screen you want to print, just press function and print, which isn't very useful. And if you look in the programmer's guide, it gives you a little more information. So I typed in one of the programs there, and we'll try to run it now and see if it works. Printer test, and then it'll pause. E0 at 110 IO error. Oh, that's not good, is it? I did notice that this connector is rather loosey-goosey. So if we look at opening channel 1, device 12, it'll not add a carriage return at the end of each line. We're opening it for output. So let's do this manually. Open number 1, comma. Gosh, if I could type, I'd be dangerous. I/O error 255 number 1. Let me look that up. Okay, I've switched the setup here a little bit, as you can see. The error 255 means that it timed out trying to talk to the device you're trying to talk to. I ohmed out this cable. All the wires are good, but all of the female terminals in here are spread open. This won't fit any, well, anything. So I don't know what somebody tried to plug in there, but you can see some dents along the bottom row, like maybe they were trying to jam in some big pins in there. I don't know, and I don't know how you'd go about trying to fix that because this is a molded over plug. You can't take it apart. So I used a couple of dock to hex adapters and ribbon cable. These are all on my website. We make these for the Hexbus adapter. And now if I run this program, probably can't see it here, it says printer test. And if I hit enter, it does print out. And the paper feed works. Okay. So we have a funky connector on the cable. As I said, I'm not exactly sure what I can do about that, but the printer itself works, which is good. We need to see if the modified button extension, this little guy here, to see if he works with the cover on before taking the protective sheet off the double-sided tape and sticking the printer in place. Yeah, and I really need to sort out this cable before doing that permanently anyhow, because we'll have the printer stuck both top and bottom. So let me take this apart a little bit so we can get to the point where we can test this button. Okay, I got the cover roughly back into position. If I push it all the way down like it would be screwed down. So the stack up of our little extension, which was the stem from the old switch, and the new switch is a little too tall. Not by much though, so maybe I'll sand, ½ millimeter off of that, and we'll give it another try. Okay, here we go. Cover down firmly. And I just sanded about ½ millimeter off of that extension we put on there. The very end of that, of the original button stem, is castellated, and I basically made it smooth, and that is just perfect. It pops up flush, and you can hit it, and it works fine. So, yeah, I'll think about how to fix this cable a bit more. I don't know if that's possible. Well, you'll notice I'm using this cable again, and you might see some extra screws right there. So I was able to fix it. I'll show you how in just a second, but first I'll show you that it runs. Run our test program again. So it does work. Go ahead and turn this off, unplug our printer, and I'll show you what I did with this cable. You notice that it plugs in there nice and firm now, whereas it practically fell off before. I didn't notice till I took this apart that the black connector body here, let me zoom in a bit. Looks like it's in focus. Okay. This part was recessed in here a couple millimeters. And I took this thing apart. And these screws weren't here originally, obviously. And I thought this whole thing was overmolded. And I noticed that the strain relief was a different color. And that this was hard plastic. So I took an X-Acto knife and pushed here. And got this to crack. Did the same thing with the other side. And was then able to get these two cover halves off of there. So you'll notice these little studs right here that the screws go through, that is a piece I 3D printed. It kind of looks like this piece, but the little towers there are longer. I called this a bridge. And you can see it's just got a little nub there on the front. Well, that nub presses up against the back of the connector. There was a little spindly, about 1 millimeter diameter piece, 2 of these back here, but that had been broken. Somebody must have tried to jam this in, and it broke those and allowed the whole thing to slip back. And I didn't want to epoxy this in there, because you never know if you're going to get it exactly right. You could have problems with it in the future, that type of thing. So took a break, watched some Stargate, thought of this bridge part. It only took a couple minutes to print. Printed a second one that was a little longer, so it fit in between the case halves, and that was just fine. The screws I got out of my junk box, they were a couple millimeters too long, and you can't really hold those trying to, you know, grind them on the bench grinder. But I still had this guy that was a little too short, so I screwed him through here, and that made a perfect fixture for grinding the screws a little shorter. So now, this fits right on here like this, and yeah, the screws are kind of ugly. Maybe I'll find some countersunk ones in the future and try to do that. But most importantly, it works. And it looks fairly decent, so I really can't complain with this sort of fix. That wasn't too hard, it just took, you know, taking the time to think about it. There we go, we got it all back together, and now we have a disassemblable, repairable, working connector. Oh, also, I'll pop some pictures up here. Those terminals were spread apart. So when I had that out of there, I took that metal shell off, and I took a small screwdriver and poked each one of those down. The terminal contact, there's a piece like this from the back that should be straight across, and there's a curved down piece like this. And if this is your pin, the pin comes in and presses on that curved down piece. And this flat piece at the top is supposed to provide extra spring pressure. Well, the flat pieces were bent up like this. So you push down here a little bit, and then I test fit each pin and made sure there was some drag. That worked fine. That was a little fiddly, but it got the job done. And now we have our printer all fixed up. Just got to put the cover on it like that. I didn't take the outer layer off the double-sided tape. I'll kind of wait to see if there's any problems with this after a little bit before I do that. I may just leave it like that. I don't plan on traveling with this where, you know, the printer mechanism is going to get shifted out of position or anything. This cover is a real pain in the butt. I think I mentioned that before. Yeah, that's not the easiest thing in the world to use. And this part here was scratched up, so I took some plastic polish and polished that. This does have a pass-through for the Dockbus, so like you can hook the cassette interface up here or some other, you know, device like that. So at least they were thinking there. Okay, so we've got our cassette deck. This we refurbished, I don't know, a year or so ago. This is a generally electric tape deck that they made specifically and marketed as a computer program data recorder. It does have a nice pause button up here, counter. It's pretty heavy duty. And the volume button here has a silver mark on it, which is the perfect spot for computers, and it does seem to work well. So you might just be able to see here, we've got our printer test program in here. And I've got record and play pressed on here. The interface has remote control over this guy. So if I type save quotes 1.test, oops, I can't spell, test.nm, closing quotes. So the 1 is the device number, which is the cassette interface. We don't have to open a channel first. Test is the file name. .nm tells it not to pop up any messages. It can pop up messages to guide you through the process, which can be nice because it'll pop up a position message, which will enable the remote and allow you to fast forward, rewind the tape, things like that. So right now I've got the pause off, record and play down. I've got the volume set in the indicated spot on the side. There's a little silver dot on the volume control where you're supposed to have for computer use. It's there. So I'll press enter. You might just be able to see the tapes moving. And our LED came on, so it's recording. And it turns on the I/O LCD annunciator here. We started about 2 on the counter, which is well past the leader. About 10 on the counter, so we went from 2 to 10. Okay, now I'm going to take a leap of faith and type in new. Okay. And then I'm going to unplug that remote line, hit stop. One nice thing about this guy is it has this pause button right here. So I'm going to wait till I see 2 on the counter. I'll press pause, stop, plug the remote line back in. Now again, if I was using the guided prompted messages on here, I could leave the remote line plugged back in. I'm going to take pause off, press play, and I'm going to type in OLD. Remember, we don't have load, we have the old command for some reason. Quotes, device 1 dot test dot no messages. Okay. We got the record play light on. The tape is moving. The I/O annunciator is on the LCD. And this is another one. You need to look in the programmer's reference guide for how to use this stuff. This is all that comes with the cassette interface. It tells you how to plug it into the computer and how to plug the cables in. That's about it. And we're up to about 9 on the counter and it stopped. So if I type in list, we have our program there. And we could plug the printer in here and plug this into the back of the printer and have both online at the same time because they have different device numbers. And that's the whole point of the Hexbus. Just for the heck of it, what do you say we disconnect the interface and we pop the cover open and see what's inside? Okay. CI-7 cassette interface assembled in Taiwan, number 6001692. And this screwdriver just barely fits in that hole. But this is a nice screwdriver. It's a Weehaw number 1 Phillips. There's one of them all the way out of there. Now, a couple of years ago, before I could find one of these interfaces, because they're not all that plentiful, I made an adapter to use a Commodore dataset in place of this guy, which worked just fine. You know, it wasn't going to be compatible with any tape saved with this guy, but you could sure load and save to your TI-95 or 74. I'll put a link to that in the description below. Oh my gosh. There, that was a little difficult to unplug. So there's that cover. Here's this side of the board. So Chips are right side up this way. 74 HC367 and an LM358. 5 transistors it looks like. I don't know what that's for. That's kind of odd. It's like a button, but it doesn't really do anything. Oh, it's but that's a bit of conductive rubber. This goes up there, so it's to bleed off a static charge. And no components on the back side. Pretty simple device. The tape output on this is just a serial out. The whole output bus is only it's a 4-bit parallel bus, but it only uses one of those for data for cassette output, and one for input, and then it has a third one that it uses for the remote line. And how was that in there? Like that? Like that, maybe? Yeah, I think like that. So the connector's about what we saw in the printer. Yep, not much to that guy. They're a little hard to find. But now that we've got the Hexbus USB serial adapter, that's what I use. Oh my gosh. So see, that's pretty clever. That looks just like a foot, but it is more than a foot. It's even more than 12 inches. Imperial measurement humor. I guess I can tell imperial measurement jokes. Every time I tell a metric joke, somebody gets upset. Y'all just have no sense of humor. There we go. We got it back together now. And I guess we'll look at those Oddball TI-74s I have setting out. Okay, here is our first Oddball TI-74, and you notice it says Mortgage Mate here. And if we look at the inside, Mortgage Solutions for Real Estate, the loan officer. So this was a use of pocket computers back in the day. They had various units, some sharps that car dealers used for figuring out loans, that type of thing. They all had different ways of adding, custom ROMs in there. This is probably an EEPROM cart. This is assembled in the U.S. with domestic and foreign parts. So people would write their own software and sell it, and here they kind of semi-customize the thing with their own inset here, stickers on the EEPROM cart, that type of thing. And you notice this is the TI-74 Space S. So this is the later ROM that can access all 32K of RAM. And it also does not have the basic legend built into the keyboard, or on the keyboard. Oh, this has batteries in it. I didn't realize that. And if we look at the back, the date is 0991, which goes along with the theory that somewhere after about 1990, 1989 late, they went to the 74 Space S. This one comes all the way from Germany, as you can tell, Hamburg Mannheimer. And this is a similar type of thing. Customized. They have their name on here. It's a 74 Space S. They've got their own insert which pops in there. No basic legend on here. And I've got another one on the way, and then I'm going to stop buying these really. It's also from Germany, but the keyboard has been localized. So it's got German names on the keys instead of the English names, which is interesting. And the date on this one is 06 of 91. This one does not have batteries in it. Oh, it does. Gosh, I know nothing. I don't think I put batteries in these, so they must have shipped them with batteries. Oh, yes. Simply Duracell. Simply Leaky Cell. Yeah, okay. I'm going to have to clean these up a little bit. These are actually in fine condition, though. I just bought them because they were a little different. You know, this had the printing on here. They customized the case a little bit. And this one's a little sad. It's got a broken case. I'm not quite sure yet how to fix it. And you notice that says PidWiz. What the heck is a PidWiz? Well, you can look up here, PidWiz Loop Tuner. So this is for tuning PID loops, a proportional integral derivative, which is a servo motor type of control algorithm. So this is just software to help you do that. I actually dumped this cart already. I'll put a link to that below, but this is a regular TI-74, no S, no space S, no batteries. Yes, for reals, no batteries, no battery corrosion. And this one is a 1987. So, I'm not sure what type of plastic this is. I don't think it's ABS. It's awfully flexible. Maybe it is ABS with a little more flexible stuff added to it. PETG maybe. I don't know, but you can see it's really busted. But it did its job and it protected the computer. So I'm not sure what the best glue to glue that with is, so I'll do some research into that. I don't think we'll include it in this video because this video is already long enough. As I was finishing up editing this video, the long-lost TI-74 showed up from Germany. The seller had put the wrong house number on it, and USPS somehow managed to still get it here. Here we have the outside of the plastic carrying case that says Alliance, the company name. Then we've got a shot of the keyboard. Note the localized German keyboard. That's pretty nifty, I thought. This is a TI-74S or Space S, I'm not sure which. The date on the back is 1989. 10th week of 89, so it could be either. I haven't got it cleaned up and put batteries in it yet to check. Well, didn't get quite as far as I hoped. We did get most things accomplished. It took a while to fix our little printer here. I guess just because it's small in size doesn't mean it's going to be easy to do. Taking care of that button was a bit of a chore, figuring out what to do there. Then we got thrown a little sideways with the connector. Had to do some Ozark engineering on that to get it working. We found out that the printer mechanism was taped in, which is really odd. I don't know how I feel about that. I understand why they did it. It was simple, it was easy. The tape also served to hold the flex cable in place. It added some noise dampening. It's just cheesy. And we looked at some of these Oddball TI-74s, and we even got to test out the CI-7 cassette interface and found it works just like you would expect. You can save and load to a cassette. And if you have a good working cassette deck, and like I said, this one has a marked spot to leave the volume. I put the tone in the middle, and it was made for this purpose. Works great. Now, used to have one of these back in the day. This is not the one from when I was a kid, but and it just always worked. Still not as nice as a disk drive, but what are you going to do? Anyhow, if you have any questions or comments, let me know. I'd love to hear from you. Thanks to everyone who helps support the channel. I really appreciate it. You guys keep me going. And until next time, bye.